time still seems like the most reliable thing for modern people. From the alarm clock ringing at 7 a.m. in New York to being stuck in traffic at sunset in Los Angeles, everyone lives their life divided into minutes. And this system is so deeply ingrained that we talk not about time itself, but only about its inadequacy. Nobody asks, "What is time?" Only, "Why can't I keep up?" Someone walking among skyscrapers in Chicago and someone driving for miles on the highway in Texas share the same feeling. Days are shortening, weeks are blurring, and years are slipping away like episodes of a Netflix series. Therefore, time is no longer just a physical measure. It has become a psychological pressure, a mental weight. However, at the point where modern physics has arrived, the feeling that time is constant is seriously beginning to crack. Mathematical models suggest that time may not be a fundamental component of the universe, but rather a functional but deceptive interface created by the brain to manage reality. In other words, clocks, calendars, and chronologies may not be reality itself, but rather mental tools created to help us tolerate reality. This thought is unsettling because, if true, there's a far deeper connection than we imagine between the future anxiety we feel walking down a Boston University campus and the sense of time lost under the neon lights of Las Vegas. Perhaps what we call flow isn't universal. Perhaps the distinction between yesterday, today, and tomorrow is a temporary map constructed by the mind to avoid getting lost in a chaotic universe. The science is clear here, but not romantic. As Newton predicted, there is no absolute time governing the universe with a regular metronome. As Einstein demonstrated, time is distorted by speed and mass. A clock atop a skyscraper in Manhattan doesn't measure the same thing as an atomic clock on a satellite in orbit. This isn't a mystical claim. The daily correction of GPS systems is a technical requirement for them to function properly. Otherwise, even Uber maps would completely malfunction within a few hours. But the human mind doesn't stop there. The moment science says time is warping, the mind asks, could the acceleration I'm feeling also be real? This is where scientific data and metaphysical interpretations intertwine. A programmer in San Francisco feels time disappearing while coding with deep focus for hours. On a beach day in Miami, a few hours fly by in an instant. In New York, under intense stress, a minute feels like hours, while moments of deep flow are compressed into seconds. This is no coincidence. Science explains this in part. Consciousness rescales the perception of time according to the amount of information being processed. The more intensely the brain works, the smaller the moment we call now becomes. Looking back, the brain finds fewer reference points, and time is perceived as compressed. This is a measurable and testable phenomenon. But science falls silent here. In this silence, the concept of frequency comes into play. Some narratives say that consciousness is in a state of vibration, and when this vibration intensifies, perception sharpens, and therefore time accelerates. This is not a physical measurement of frequency. Rather, it is a symbolic language that describes experience. It is not scientific, but it is not entirely meaningless either, as it attempts to describe human experience. Science explains not whether time is actually speeding up, but why we feel like it is speeding up. Mystical narratives, on the other hand, suggest that this feeling stems from consciousness shifting to a different mode of reality. The critical point here is that both approaches look at the same experience, but speak different languages. Relativity teaches us one thing for certain: everyone's time is not the same. It could even be said that someone living at a high altitude in Denver theoretically has different rates of time than someone living in New Orleans. This difference is not felt in daily life, but it is real for the universe. The human mind wants to take this knowledge a step further and whispers, if time is so flexible, perhaps it doesn't flow forward as we think. From here, we move on to the idea of a block universe, the thought that the future already exists, and quantum interpretations. At this point, it is no longer precise science that speaks, but interpretations that hover around the boundaries of science. The moments when we feel time speeding up don't indicate a change in the universe. On the contrary, they show that our window of consciousness is narrowing. However, this awareness is not innocent, because it leaves us with the thought, perhaps time isn't carrying us. Perhaps we are passing through it. Stop and think. If understanding this universe excites you, don't forget to like this video and subscribe to the channel. Turn on notifications for more mind-boggling and fascinating cosmic content like this. Your clock is lying. Time isn't what you think. The clock you see on your phone screen, the digital numbers you check on your way to work, or the countdown to the next train on the New York subway. These aren't the truth itself. They are elegant but necessary corrections to hide a far more disturbing truth. Because time doesn't flow at the same speed for everyone, and never has. This is a silent secret that the modern world chooses to ignore to maintain its order. The difference in the flow of time isn't just about speed. Yes, a passenger flying from Los Angeles to Tokyo, even while sipping their coffee in their seat, technically makes a small leap into the future compared to someone remaining on Earth. But the real dark factor isn't speed, it's gravity. Gravity doesn't just slow time down. It crushes, compresses, and suffocates it. It descends like a blanket over the clock, stretching the gaps between its ticks. It's a great misconception to think of gravity simply as a force pulling you to the ground. As Einstein showed, gravity is a warp in the fabric of reality. The closer you get to a large object, the more space warps and the heavier time becomes. As you descend deeper into the gravitational field of a large object like Earth, the flow of time slows to an almost imperceptible level, yet it still relentlessly continues. This reveals a deeply unsettling truth. Even different parts of your body don't experience time at the same rate. Your feet, being closer to the center of the Earth than your brain, technically age slower. Your brain cells exist at a different rhythm than your heart, your bones, and your toes. This difference, though an incredibly small nanosecond slice over a human lifespan, is significant. This means you are not a single, unified temporal entity. You are a complex collection of parts flowing through time at slightly different speeds. While this idea might seem philosophical at first glance, it was definitively confirmed by a concrete experiment conducted in America in the 1970s. In 1971, physicists Joseph Hafele and Richard Keating took extremely precise cesium atomic clocks and traveled the globe on commercial passenger planes. One plane flew east, the other west. Throughout the journey, the clocks were exposed to different speeds and different gravitational potentials. At the end of the journey, these clocks were compared to stationary reference clocks at the U.S. Naval Observatory in Washington. The results were disturbingly clear. The traveling clocks did not show the same time as the clocks that remained on the ground. As Einstein predicted, the moving clocks, exposed to different gravitational fields, carried different amounts of time from the past. Unbeknownst to them, the passengers were carrying a fraction of a billionth of a second into the future. This difference seems small on Earth, but stretch your imagination. Imagine standing near the event horizon of a supermassive black hole where gravity is millions of times stronger than on Earth. A few hours spent there could mean centuries for the rest of the universe. While you enjoy a quiet lunch, civilizations rise and fall in galaxies. Stars are born and die. This shows that time behaves not like a rigid arrow, but like a fluid substance. Sometimes it's heavy like thick syrup. Sometimes it flows like water. Time slows down as we get closer to the source of gravity. It speeds up as we move away. The Earth's core is younger than its surface. The core of our galaxy lags behind its spiral arms. We don't move in a straight line. We drift in a turbulent ocean of time, where deep currents slow us down and the surface speeds us up. And if time can stretch like rubber, depending on gravity and speed, an inevitable question arises. Can time reverse itself? Einstein's theory of general relativity allows for solutions called mathematically closed time curves. These describe paths where space and time are bent so violently that they return to their starting points. If such a path exists, theoretically, a portal to the past is possible. And here's physics' most famous nightmare, the grandfather paradox. Imagine you find a wormhole and can travel back 60 years. Driven by curiosity, fear, or pure madness, you encounter your grandfather before your father was born. An argument ensues, and you kill him. This single act erases your existence. Because if your grandfather dies, your father is not born. If your father is not born, you are not born either. But if you had never been born, you couldn't go back in time, find the wormhole, and destroy it. That would mean your grandfather would still be alive. An endless loop of logic would occur. You both exist and don't exist at the same time. This is a contradiction that the universe cannot tolerate. It's an inconsistent situation, like the twin paradox, but not intuitive. It completely destroys the cause and effect relationship. If an effect can override its cause, then the laws of physics lose their meaning. Therefore, either time travel is absolutely forbidden by an unknown law of nature, or our intuitions about reality are far more flawed than we think. And perhaps the truly frightening thing is this: the problem isn't time. The problem is that we think we understand it. If what you've heard so far has raised even the slightest question in your mind, this information shouldn't remain just with you. Such ideas only reach those who are truly seeking them when they are shared. By liking the video and subscribing to our channel, you're helping this content reach the right people instead of getting lost in algorithms. Perhaps this video is exactly what someone else, silently pondering the same questions, needs right now. Do you think repeating the same life forever is a blessing or a curse? Share your thoughts in the comments and discuss with other viewers. If there's no escape from time, free will, or multiverse, there are two main proposed solutions to escape this logical nightmare facing physicists. And ironically, both are more disturbing than comforting. Because whichever solution you accept, you either have to give up your free will or accept that you've left behind a reality you can never return to. The first solution is the principle of self-consistency, put forward by Russian physicist Igor Novikov. According to this approach, the universe is not a passive stage. It behaves like an active, flawless system that preserves its own history. When you go back in time and try to kill your grandfather, the universe activates the laws of physics like an invisible security system. The moment you pull the trigger, your gun jams. It slips from your hand. The bullet misses the target. Or you don't kill him. You just wound him. And that wound becomes the reason he meets your grandmother. History is preserved under all circumstances. This scenario preserves logic, but it comes at a terrible cost. Because in this case, you are no longer a decision-making subject, but an extra playing a role in a pre-written script. Imagine performing on a stage in New York. Your lines aren't yours. You can't improvise, and you're forbidden from leaving the stage. No matter what you do, the timeline pushes you back to the right point. Free will exists only as an emotion. This leads to a disturbing question. If the past cannot be changed, are the decisions we make in the present truly our own? Or are we merely obligatory links in a predetermined chain? The second solution is far more dizzying and relies on the multiverse interpretation of quantum mechanics. According to this view, the universe is not a single timeline. It's like a vast network of constantly branching highways, starting in Brooklyn and diverging in different directions at every intersection. When you go back in time and kill your grandfather, you don't erase your own existence. You just switch to another branch. The original timeline, where your grandfather lived and you were born, continues to exist, but it is no longer accessible to you. The future you alter is not your future. You're trapped in a universe you don't belong to. You become a kind of temporal refugee. You can't go home because home is now part of another reality. In this scenario, there's free will, but the price is loneliness. And it doesn't end there. Just when you think time loops are strange enough, physics takes you a step further and confronts you with the bootstrap paradox. This paradox questions the origin of knowledge and objects. Imagine you're a Shakespeare fan. You travel to Elizabethan England in a time machine. But when you find Shakespeare, you realize he wasn't the kind of person who could write great works. You can't bear the loss of world literature. You pull a book from your bag containing all the Shakespeare plays you bought in the future and give it to him. He copies the plays and publishes them under his own name. History is preserved. You return to the future. But now stop and ask yourself this question. Who wrote these plays? Shakespeare didn't write them. Neither did you. The book existed within a closed time loop. Knowledge was never invented. It only circulated. The same is true for objects. Consider a pocket watch you gave your grandfather. The watch passes through generations and eventually comes back to you. You take the same watch, go back in time, and give it to your grandfather. The watch has no manufacturer. It was never made. But it continues to exist. This shatters the cause and effect relationship. Within the framework of general relativity, this is logically possible, but mentally jarring. It forces us to think of the universe not as a chain of events, but as a flexible space-time landscape. When this landscape is sufficiently distorted, time ceases to be a straight road and becomes a Ferris wheel. Events become their own causes and their own effects. And here is the quietest but most devastating consequence of time. There is no universal now in the universe. Einstein's theory of simultaneous relativity states that even two people walking on the sidewalk in Los Angeles don't agree on the present moment of the universe. As in Roger Penrose's Andromeda paradox, if one galaxy is moving toward another, what's happening in Andromeda might be happening at different times for them. For one, the alien fleet has already set sail. For the other, no plans have even been made yet. This points to a single truth. There is no shared understanding of what is currently happening in the universe. And perhaps the most disturbing consequence is this: we don't live in time. Time lives through us. Consider this. If we are moving relative to the stars in the sky, and even this movement changes our perception of time, then what we call now cannot be a single, common boundary progressing in the universe. A moment you experience may not yet have arrived for me. This tells us that the present moment is not a universal line. It is a subjective snapshot formed according to each observer's position, speed, and perspective. In such a universe, the idea that the past is completely erased and the future does not yet exist is fundamentally shaken. If an event has already occurred for one observer, but is still in the future for another, that event is neither in the past nor in the future. That event is a coordinate suspended in space-time, waiting to be encountered. This thought leads us to the most rigid map of reality offered by physics, the idea of a block universe. In a block universe, time is not a flowing river. The universe is a complete structure from beginning to end. Physicists sometimes use the example of a giant loaf of bread to explain this idea. Each slice of this bread represents a different moment in the universe. One slice represents the extinction of the dinosaurs, another, the rise of the pyramids, another, your future birth, another, your future death. We perceive only one slice of this bread. Because we remember the past, we feel it's behind us. Because we can't see the future, we think it's not ahead of us. But from a physical perspective, the whole loaf of bread is already there. No slice is missing. None is yet baked. From this perspective, time doesn't flow. The universe is like a four-dimensional frozen structure where every event exists forever. Like an insect trapped in amber, every moment is preserved. Laughter, screams, starbursts, everything is in its place. This thought transforms life from a journey into a fixed map. Death is no longer a distant possibility. It's a specific point in space-time. Just as the chair you're sitting in right now exists in a specific place. Now, in this case, you are not someone who creates life, but someone who experiences life. It's like a needle moving across an old record. Although the music seems to progress, the entire melody, from the first note to the final silence, already exists on the record from the beginning. In the block universe, nothing truly changes. The entire history of the universe exists as a single object. This idea is psychologically devastating because it directly attacks our belief in free will. Every morning when we wake up, we think of the day as a blank page. Will we turn right or left? Will we speak or remain silent? But if the block universe is true, this feeling is merely an illusion created by our brain. The future is already there. Our choices are steps taken on a path already written. When you raise your arm, this decision creates neural activity in your brain. However, both this neural activity and the raising of the arm already exist at specific coordinates in the space-time block. They were there long before you were born. From this perspective, you are not the author of your own story. You are like the main character in a script completed at the moment of the Big Bang. Einstein intuitively accepted this idea. When his close friend, Michel Besso, died, he wrote to his family that the difference between past, present, and future was merely a stubborn illusion. If all moments existed simultaneously, his friend wouldn't have disappeared. He would simply be somewhere else in the neighborhood. But the question is, if everything were frozen, why would we feel the passage of time so strongly? Why would we remember the past, but not the future? Why doesn't a broken cup spontaneously return to its original state? The answer to this question leads us to the concept of the arrow of time. While many laws of physics are reversible, one law contradicts this: the second law of thermodynamics. This law states that in closed systems, disorder tends to increase. Entropy rises. It is possible for a cup to fall and shatter. It is also theoretically possible for the pieces to spontaneously reassemble. However, this probability is so low that the universe almost never chooses this. The disordered state of atoms is astronomically more likely than their ordered state. The origin of the direction of time lies here. The reason we age is that our cells accumulate errors. The reason stars die is the dispersion of energy. What we call the flow of time is actually the process of witnessing the breakdown of order. If there were no entropy, there would be no difference between the past and the future. Life would look the same, like a film played forward or backward. And perhaps the most shocking truth is this: our perception of the flow of time is not a gift from the universe. It is the price of the slow disintegration of order. In the late 19th century, a man walked the streets of Vienna, Ludwig Boltzmann. Many of the ideas taught today on a university campus in Boston or in a startup office in Silicon Valley would have been ridiculed in his time. Boltzmann was one of the few scientists who believed that atoms actually existed. At the time, most academics viewed atoms as merely a mathematical story. But Boltzmann arrived at a revolutionary conclusion when he realized that matter was made up of tiny particles constantly moving, colliding, and dispersing like the crowds in New York. If matter is statistics, then time is also statistics. The perfect state of an egg is like the orderliness of an Apple store opening in the morning: clean, low entropy, and extremely rare. But an egg that falls and scatters, or an abandoned and decaying building, these are high entropy states, and the universe prefers them. A living human body, a functioning city, the lights on the Las Vegas Strip, these are exceptions. The rule is disorder. Therefore, the arrow of time is not a mysterious force. It is the tendency of the universe to transition from low probability order to high probability chaos. The past is ordered, the future is a statistical probability. Boltzmann saw this. However, the scientific world of that era could not accept the idea that the laws of nature could be time-dependent. They laughed at him. They ostracized him. They rejected his papers. And in the end, this loneliness destroyed him. In 1906, while on vacation with his family, Boltzmann committed suicide. Tragically, the experiments that would definitively prove the existence of atoms would only be carried out several years later. Today, In every physics class, from Chicago to San Francisco, it is taught that he was right. On his tombstone in Vienna, only one equation is inscribed: S equals K log W, the formula for entropy. This equation explains why we cannot bring back a burnt-out match. We can remember our childhood, but we cannot remember tomorrow. Why is every breath a process that wears down the universe a little more? Every breath you take increases the disorder of the universe, bringing you one step closer to that ultimate equilibrium, where one day no stars will shine, no stories will be told. Time is not a creative force. It is an erosive flow, drifting toward its end. We are islands of temporary order, like the abandoned factories in Detroit. We must accept that the universe did not choose us. We are a statistical accident. But entropy doesn't just determine the direction of time. The speed of light defines the limits of time. Relativity traps us in an invisible cage, the cone of light. Imagine you are standing on a balcony in Los Angeles right now. You are at the very center of the distance light has been able to reach since the beginning of time. Everything inside this bubble can affect you. Everything outside this bubble is forever separate from you. If the sun disappeared right now, no one in New York would notice for 8 minutes. The sun would disappear, but it would still appear to us as if it were shining. The earth would continue to rotate. Trees would continue to photosynthesize. We live in a ghostly copy of reality, and worse. As the universe expands, some galaxies are moving away from us faster than the speed of light. They are crossing the cosmic horizon. We will never reach them again. We can neither send signals nor receive responses. Not even the most powerful rocket launched from Houston could reach them. As the universe grows, we become isolated within a shrinking bubble of causality. And this isolation leads us to the question, what if it were possible to exceed the speed of light? This is where tachyons emerge from the dark corners of theoretical physics. Imaginary particles, supposedly moving faster than light, never observed. If they were real, you could predict the Wall Street crash before it happened. You could prevent the morning crash by texting yourself an hour in advance. But that's where the problem begins. Causality collapses. Cause follows effect. Time gets mixed up. The universe turns into a logical nightmare. That's why most physicists see tachyons not as real entities, but as mathematical warning signs saying, enough is enough. But the unsettling truth is, even our best theories explaining time cannot completely rule out such a monster. And this whispers to us, perhaps the universe is far more fragile than we dare to admit. Time is not a fixed clock, but a dimension that twists and turns like the highways of Los Angeles, changing as it accelerates. What we call now is an illusion created by our brains. Past and future can exist simultaneously, and we, within this vast, silent, expanding structure, are merely witnesses breathing within a cell of light. The theory of relativity tells us that time is like a spatial dimension, but quantum mechanics whispers something far more radical. Time may not exist at all, or it may be a secondary effect intertwined with matter, like heat rising from a fire. Prepare yourself, because with this thought, we are looking at the world from a completely different perspective. Cause and effect are the basic structure of our daily lives. When you knock over a coffee cup in Los Angeles, the coffee falls to the floor. When you think about a traffic accident in New York, it has an effect. But in the quantum world, this well-known fact is reversed. We call this the quantum Zeno effect. A system under constant observation cannot literally change its state. Simply put, an observed quantum pot never boils. This is not just a metaphor. In 1989, physicists David Wineland and Wayne Tano showed that the act of observation could freeze time by exposing Burrell ions to radio frequency pulses. Normally, an atom seamlessly transitions from one energy state to another. However, when scientists took measurements thousands of times per second, the atoms froze in their original state. It's like pausing a scene at a film festival in Boston and watching that frame for an hour. This experiment shows that the flow of time we perceive may be composed of snapshots pieced together by our consciousness. The universe isn't a continuous film. Our observation is writing it moment by moment. Whether walking in a park in Los Angeles or under the streetlights of New York, every time we open our eyes, we are creating the history of the universe. And it goes even deeper. John Archibald Wheeler proposed the delayed choice experiment. Consider the journey of a light photon. A photon from a star, billions of light years away, is lensed by a galaxy as it travels toward Earth. This galaxy offers the photon two possible paths: path A, going left, or path B, going right. But the photon chooses a path only depending on our observation. That is, our observation can influence the past. Imagine yourself as an American observer, measuring ions in a lab during a heavy snowstorm in Chicago, or gazing at distant galaxies through a telescope in San Francisco. Unwittingly, simply by observing, you freeze the universe, shaping the past and the future. The universe itself is a constantly changing wave function, depending on the observer's perspective. Quantum mechanics questions the flow of time while simultaneously testing our belief in reality. Time may be merely an illusion. While walking in the sunlight in Los Angeles or riding the subway in New York, the universe may be frozen at an atomic scale somewhere else entirely. And the most striking part? Existence only gains meaning when observed. If there is no observation, will a tree fall in the forest? The quantum world says, perhaps it won't even fall. Time, existence, and reality take shape before your eyes. You are not a passive observer of the universe, but an active creator. This cycle relives all the pains and joys of life, every regret and triumph, infinitely. Death is not an end, but a rebirth. Mistakes and choices constantly come back to shape you. Your courage or ruthlessness becomes a monument that will echo forever. If these ideas deeply resonate with you, share the video with your friends. They too can join this cosmic journey. The quantum nightmare and the secret of black holes. Until a photon is measured, that tiny particle of light moves in a mechanical dance. Like people running down Broadway in New York, or seagulls dancing in the wind on the Golden Gate Bridge in San Francisco, the photon doesn't follow a specific path. Like a probability wave, it traverses both paths simultaneously. And that's where the nightmare begins. The behavior of this tiny particle will be shaped by your decisions. Now imagine, you're at the telescope in the Adler Planetarium in Chicago. You decide, will you measure which path the photon will take? Left, right, or will it behave like a wave? Logic tells you that the photon's movement must have been determined billions of years ago. But quantum experiments show us another truth. The photon determines its past movement with the measurement you make today. Now imagine you're at the telescope one night in Boston. A photon wouldn't know which path to take until you decided 1 billion years ago. If you choose to go left, the photon says, "A billion years ago, I chose that path." If you measure the wave pattern, the photon says, "A billion years ago, I chose both paths." So your decision today reshapes the past. This completely overturns our understanding of linear cause and effect. The arrow of time is no longer unidirectional. The future can influence the shaping of the past. And this is where things reach catastrophic proportions in black holes. Black holes. Let's focus on the question that physicists pondered for years, while astronauts trained at the Johnson Space Center in Houston, Texas. Do matter and light truly disappear forever when they enter a black hole? In 1974, Stephen Hawking made a discovery that overturned this understanding using quantum field theory. Black holes weren't completely black. They emitted a faint radiation. This Hawking radiation slowly shrunk the black hole, eventually leading to its complete disappearance after a long period. But what about information? Let's say you threw your diaries into a fireplace in Washington, D.C. The diaries turned to ashes. Was the information lost? According to quantum laws, no. The information is preserved in the smoke. Theoretically, if you had a supercomputer, you could reconstruct the information. But if it falls into a black hole, the information shatters. Hawking's calculations show that the emitted radiation is completely random, meaning the contents of your diary or book appear to be completely unpreserved. This is where the concept of singularity comes in. Consider an astronaut boarding a spacecraft in Houston. The astronaut is gliding toward a black hole. From their perspective, they cross the horizon and survive. But for an observer in New York, the astronaut never crosses the horizon. They are stuck to the surface, burned, and simultaneously both dead and alive. This forms the basis of the black hole complementarity theory. Time and reality are experienced differently depending on the observer's point of view. To make this idea more understandable to an American audience, consider this example. Whether you're walking down Hollywood Boulevard in Los Angeles or sipping coffee in a Chicago cafe, the fundamental workings of the universe are shaped by your observations. Everything from atoms to galaxies takes on a different reality depending on your perspective. Time and the past are not as static as you might think. Your active participation as an observer ensures the constant rewriting of the universe. Quantum experiments show that the past is not fixed and that the future shapes the past. Wheeler's delayed choice experiment is one of the most striking examples. A photon may have come from a star a billion light years away, and its movement is determined by the measurement you make today. The choice you make today rewrites past events. An even more striking example, black holes can act like cosmic erasers that obliterate information. If Hawking is right, our memories, our diaries, even our history could be irretrievably lost. This means that the past could vanish, and the logical consistency of time could be threatened. This text not only explains the strangeness of quantum physics to the reader, it also strikingly demonstrates how fragile and observer-dependent the universe is, relating it to American cities and daily life. Our three-dimensional world may not be as tangible as we think. Consider this. Walking among the skyscrapers of Chicago, the reality that surrounds your entire life might actually be an illusion. To resolve the discrepancy between gravity and quantum mechanics, physicists Leonard Susskind and Gerard Tehoft came up with a bizarre proposal that seems straight out of a science fiction script. the holographic principle. Now, imagine a can of soup. Normally, we determine the vegetables, the broth, the noodles, and even the taste based on the volume inside the can. But what about objects falling into a black hole? According to Susskind, all the information about these objects sticks not to the inside of the can, but to the surface of the can, the event horizon. Just like the label on the outside of the can. The information isn't lost. It's simply transported to a different dimension. To make this a little more concrete, imagine you're sitting in a park in Los Angeles. In front of you is a road, a playground where children are running around, and the Hollywood Hills in the background. Now, this entire scene might actually be encoded on a distant surface at the edge of the universe. The holographic principle proposes that all three-dimensional objects in the universe are reflections of a two-dimensional surface. In a sense, the depth we perceive is how our brains interpret these codes. Consider a glass snow globe. Inside, there's a small house, a tree, and a few snowflakes. Now imagine the glass shell of the snow globe as a super high-resolution screen. A single event inside the globe, such as a snowflake falling, can be perfectly described by the mathematical equations governing the pixels on the surface. We are the snowmen inside this globe. We think we are moving and living in depth, but in reality, we are a shadow play created by these pixels. This also applies to time. If the three-dimensional universe is a hologram, then time may also be a secondary reflection. The seconds, minutes, and hours we perceive are actually a reflection of quantum interactions occurring at the edge of the universe. Whether you're sitting in a cafe in New York's Soho neighborhood or running along Miami Beach, time may be warped and distorted without you even realizing it. And things get even more complicated when it comes to black holes. While astronauts were training at a space center in Houston, scientists believed for many years that black holes swallowed matter and light and never returned it. That is, until Stephen Hawking overturned this understanding in 1974. Black holes aren't completely dark. They emit a faint radiation that causes them to slowly shrink and eventually disappear over time. But what about information? Let's say you threw your diary into a fireplace in Washington, D.C., and it perished in the flames. According to quantum mechanics, information doesn't perish. It's preserved in the smoke. Theoretically, if you had a supercomputer, you could reconstruct that information. But if it falls into a black hole, the information disintegrates, and according to Hawking's calculations, the emitted radiation doesn't seem to carry that information. This creates the concept of a singularity. Now let's move on to the astronaut's story. He boards a spacecraft in Houston and glides toward a black hole. From his perspective, he crosses the horizon and survives. However, a distant observer, say someone in Chicago, might see the astronaut as if he never crossed the horizon, stuck to the surface and burned up. Both are simultaneously dead and alive. This is the basis of the black hole complementarity theory. Time and reality change depending on the observer's point of view. And this is where the concept of a white hole comes in. While a black hole is a trap you can enter but not escape from, a white hole is the opposite. Instead of a door you can enter but not escape from, it's a region of space that ejects everything. Mathematically, black holes and white holes are like opposite poles. At the boundaries of the universe, this leads us to question how time and space work. Consider this. Sitting in a cafe in Seattle, your gaze might be influencing the flow of the entire universe. Quantum particles, galaxies, and black holes all are shaped by your observations. Time is not linear. The past, present, and future are constantly being rewritten by our observations and choices. In conclusion, the holographic principle and black hole theories tell us this: the universe is not as tangible as we perceive it. Our three-dimensional world, the flow of time and reality, may be a hologram, constantly being shaped by the observer's active participation. We are characters, digital avatars, playing within this vast simulation. Whether we walk the crowded streets of Chicago or sunbathe on the beaches of Miami, we are consciously encoding the universe. The inner journey is like the impossibility of going back to last Tuesday. For years, white holes were seen as a mathematical curiosity unrelated to reality. Even a single speck of dust trying to enter would collide with the outgoing matter, and the system could turn into a black hole. However, the discovery of dark energy and the rapid expansion of the universe have revived interest in these improbable objects. Some cosmologists have suggested that the Big Bang was actually a white hole leading to the birth of our universe. That is, a universe that arose as the output of a black hole. This theory tells us that time is not just a line. The past, present, and future are interconnected like a cosmic network of pipes. Let's delve deeper. Cyclic quantum gravity argues that space is composed of infinitesimally small geometric grains, just like grains of sand. These grains prevent the catastrophe of the classical singularity theory. When a star collapses into a black hole, it is compressed into the smallest quantum dimension of space. It is now insoluble. These quantum particles begin to counteract gravity by creating a powerful repulsive force. And that's where the quantum leap comes in. Matter doesn't stop or disappear instantly. It bounces, reverses, and explodes away. The black hole effectively transforms into a white hole. But the elasticity of time makes this explosion appear almost instantaneous. While it lasts a millisecond in the star's own time, billions of years pass when we observe it from the outside. This theory proposes that every black hole in the universe is actually a pregnant baby universe. When the black hole evaporates and gravity disappears, the white hole explodes into our reality. Matter swallowed in the past becomes visible again. We understand that time is not an annihilator, but a motor that preserves the past in a quantum vault. And now, let's go back to John Archibald Wheeler and Bryce DeWitt. In the late 1960s, these physicists aimed to create a single equation describing the universe by combining quantum mechanics and general relativity. But they noticed something. Time vanished in these combined equations. The Wheeler-DeWitt equation stated that the universe existed in a frozen, single, and infinite configuration. There was no past, no future. Time itself was merely an illusion. Imagine a film reel. The reel is divided into thousands of frames, lying in a chaotic pile on the floor. Each frame represents a moment in the universe, but the reel itself doesn't move. The illusion of movement arises from our conscious perception. This view, known as frozen formism, argues that time is not a fundamental property of the universe, but merely a user interface created by our perspective. And the strangest part? The universe has two fundamental pillars: general relativity and quantum mechanics. Both are incredibly successful, but they have a fatal disagreement: the nature of time. In relativity, time is elastic. In quantum mechanics, it is frozen and static. This is one of the greatest crises of modern science, the vacuum catastrophe. In short, time, past and future, black holes and white holes, quantum particles of space. They are all interconnected. And perhaps, while walking the streets of Chicago or running on Miami Beach, we are consciousnesses existing within a giant hologram in a timeless universe. For years, physicists have been trying to understand the extremes of the universe: big bangs, black holes, and superdensities. But when these two fundamental theories, general relativity and quantum mechanics, try to converge, the mathematics is often filled with nonsensical infinities. The bottom line is this: quantum mechanics requires a constant time background to calculate events, while general relativity says that gravity can bend time. This isn't just a technical problem. It fundamentally shakes the way we perceive reality. Who knows? Maybe time isn't one of the fundamental components of the universe. Maybe it's an illusion, like the smooth surface of water, hiding the chaotic molecules beneath. In 1983, Don Page and William Wooters suggested that time might actually be a side effect. Imagine the universe as a frozen, static quantum field. Everything is frozen. All energy is zero. But to an observer looking from within, something miraculous happens. Through measurements and entanglement, the flow of time is perceived. The clock ticks. Events seem to follow a sequence. The system is frozen, yet we perceive the illusion of movement. Time is not a dimension, but a relationship. This idea has been experimentally confirmed. In 2013 in Italy, a system of entangled photons showed clear evolution internally, even though nothing seemed to change from the outside. So time, like heat, is an emerging property. Without the interaction of atoms, time could not exist. The entire universe would remain static. But the most frightening part is a hidden danger in particle physics: vacuum decay. Modern physics doesn't see the vacuum as nothingness. Quantum fields, electrons, the Higgs field, they all float in the vacuum. Quarks and the Higgs boson make atoms and mass possible. But calculations show that the vacuum we are in may not be the true lowest energy state. Imagine this. We feel like we are at sea level, but we are actually on top of a high mountain lake, and a fragile dam is holding us down below. If this dam breaks, everything in the universe will instantly disappear. This is vacuum decay. If the Higgs field exceeds its energy limit and falls into a true vacuum, atoms will disintegrate, stars will die, chemistry will become impossible, and life will end. This is a catastrophe lurking in the universe, like a time bomb. A quantum fluctuation is enough. A true vacuum bubble will form and expand at the speed of light, potentially encompassing the entire universe. Your brain vanishes before it even has a chance to convert the sensation of pain or fear into an electrical signal. No screams, no panic, no discernible moment. This is the most instantaneous form of death possible. It could be 1 billion years from now, or the moment you hear it, exactly 5 seconds later. Like a cosmic sniper shot, you never know you've been targeted. What's even more disturbing is this: once this event begins, it can never be stopped. Once the actual vacuum bubble forms, there's no turning back. Expanding at the speed of light, it swallows everything in its path, transforming the entire observable universe into an alien physical regime where life is impossible. For complex beings like ourselves, time is the measure of change and evolution. But in this scenario, time abruptly ends. It gives way to the sterile, timeless physics of the actual vacuum. No past, no future. Just cold, absolute silence. This possibility, dubbed the Great Swallow, makes all our human anxieties about the future almost ridiculous. We discuss the climate crisis, wars, the fact that the sun will die in billions of years. Yet, in reality, we stand on the threshold of a cosmic trapdoor that could open at any moment for no reason. Even the stability of time is not guaranteed. Every second we win, until we lose. If the physical destruction of the universe isn't enough to keep you awake at night, let's move on to something even more disturbing. A paradox that directly targets your mind and memory. Boltzmann brains. This idea is born at the intersection of infinity and entropy. We know that the universe is prone to disorder because disordered states far outnumber ordered ones. But if the universe is infinite, or unimaginably large, even extremely low probability events eventually become inevitable. Quantum mechanics allows for random fluctuations of particles. Most of the time, these fluctuations are insignificant. A pair of particles appear and disappear. But given infinite time, these fluctuations can bring together an atom, a molecule, or even a fully formed human brain. Mathematically, this is inevitable. Here's where the problem begins. Creating a universe like ours, with billions of galaxies, undergoing 13 billion years of cosmic evolution and producing conscious observers, is incredibly difficult. It would require an extraordinarily low entropy state at the Big Bang. This is statistically almost impossible. But it's far easier for a random quantum fluctuation to create a single brain with memories. A brain filled with memories of a past that never happened, existing for a few seconds and then returning to chaos. This entity is called a Boltzmann brain. And the trap is this. If we accept the laws of statistical mechanics, there would have to be countless times more Boltzmann brains than actual biological brains. For every real human being on Earth, there are trillions of false consciousnesses that believe themselves to be living on Earth. This inevitably leads to the question, are you a real human being, born of parents, with a real past, and aged over time? Or are you a Boltzmann brain, carrying false memories from a second ago, your childhood, your family, and this video you think you're watching right now? This paradox isn't just a creepy thought experiment. It's a result that fundamentally undermines science itself. Because if we are Boltzmann brains, our memories are unreliable. Textbooks, experiments, the history of science may all have never happened. They may just be random data patterns encoded in a temporary neural network. This is an epistemological collapse, a situation where we can't trust anything we think we know. Furthermore, it includes the physics arguments that led to this conclusion. Cosmologists take this problem seriously, because if our theories say we are nothing more than random fluctuations, then those theories are wrong. We observe an ordered, coherent, and continuous universe. This means the universe is either not infinite in time, or it won't last very long. The only way to be sure we are true observers is to explain why the universe started so orderly, and why time flows from the past to the future. Because if this flow is just a statistical accident, then you are probably an accident too. Perhaps the greatest paradox of time is not when it will end. It is whether the past it presents to us was truly lived. Are we watching a story written by chaos? Or are we really here? Everything is like a dance. Molecules repeat, experiencing each possible configuration individually. If you wait long enough, the system begins to recreate itself. Atoms, stars, you. Everything reshapes itself in a cycle. This is Poincaré's repetition. The universe, down to the last neuron in your brain, relives its exact current state over and over again. If mechanical laws apply, this is not a possibility, but a certainty. In a closed universe, time is not linear, but circular. This cycle causes you to relive all the pains and joys of life, every regret and triumph, forever. Death is not an end, but a rebirth. Mistakes and choices constantly return to shape you. Your courage or ruthlessness becomes a monument that will echo forever. This is the ultimate test of affirming life and accepting fate. But for most people, this is not strength, but paralysis. Determinism shows that we cannot change anything, and that progress is an illusion. Every step, every choice is repeated in an endless cycle. Consciousness is being questioned as to whether it is a gift or a curse. If we are in this prison, it means we are condemned to confront our own identities forever. But the universe offers a way out. The Big Rip. Dark energy is accelerating the expansion of the universe, eventually becoming powerful enough to shatter all its structures. The universe, slowed by gravity, is rapidly heading towards disintegration through uncontrolled expansion. Like a cosmic countdown, the Big Rip is the universe's chance to escape the endless cycle by destroying itself. Thanks for watching this video. Follow our channel, comment, and turn on notifications for more cosmic secrets and mysteries of the universe.